Welcome to today's lesson on adding and subtracting fractions. In today's lesson, we will talk about fractions and parts of numbers and how we can combine them or take one away from the other to complete math problems. Looking at the basic definition of this topic, we understand that fractions, just like all numbers, like integers, can be added or subtracted to complete math problems and for us to think about different amounts. Well, why would we want to do this? Image-wise, let's imagine that we have a pizza with 3 slices left. Somebody else has another pizza with 2 slices left. We take this opportunity to think about, well, how many slices do we have together? And altogether, we would have 5 slices out of a possible 8. I added the 3 over 8 and a 2 over 8 to give me a 5 over 8. So how do I write this? How do I think about adding fractions? How do I think about doing these math problems carefully? I start off with 6 over 9 and add 2 over 9. In this case, since my numerators are different, I will add them together, 6 plus 2, giving me 8, and I'll leave the denominators the same. I do not add the denominators 9 and 9, giving me a final answer of 8 over 9. And looking at the next problem where I can subtract. 10 minus 6 on the top gives me a 4, and my denominators, in this case 13, stays the same. So my final answer would be 4 over 13. But what if the denominators are different? What if I get a math problem where I don't have the same denominator? Take a look at this example. This pizza has 8 possible slices, while this one has 6. So how do I combine the slices to know what amount I might have at the end of the day? Thinking about it, this slice has 3 out of the 8 possible slices, and the other pizza has 2 out of the possible 6. How do I complete this problem to correctly solve it? Taking us back to least common multiple, I must transform the fractions into a way where they'd have the same denominator to allow me to complete the problem. So again, 3 over 8 plus 2 over 6. Let's find the least common multiple of 8 and 6. If I can recall back and think about the process of least common multiple, in this case, the least common multiple between 8 and 6 is going to be 24. Thus, the new denominator for each fraction will be 24. But how do I go from 8 to 24? I times by 3. So my numerator for the first fraction is 6, and my numerator for the second fraction in this case is going to be 8, because 6 times 4 gave me 24. Now that my fractions have the same denominator, I can simply add the two together, 24 is the denominator, and get 14. Picturing it, how do we imagine how this works? Well, again, looking at the top 2 squares, I see that I have 2 gold squares out of a possible 4. How do I add that to a similar diagram where I have 1 gold square out of a possible 3? Transforming into the bottom 2 squares, I see that I have 6 out of a possible 12 and 4 out of a possible 12. Since they're both out of the same denominator, I can combine the 6 and the 4 to give me 10 out of a possible 12, thus solving this same problem. Moving forward, let's take a look at a few other examples, and let's take a look at some practice where maybe we'll have to work backwards on these things. Let's imagine 4 over 5 minus 2 over 3. Let's find the least common multiple of these problems. 5 and 3 least common multiple in this case is going to be 15. So let's put a 15 as the denominator for both of the fractions that I'm going to subtract. 5 times 3 gives me 15, so the 4 times 3 is going to give me a 12 here on top. And since 5 times 3 gives me a 15, 2 times 5 gives me 10. 12 minus 10 gives me 2. My denominator stays the same, final answer of 2 over 15. In the next example, let's reduce 15 over 20 minus 8 over 16. Let's make our denominators smaller and let's make them the same number. 20 and 6, I'm going to be thinking about greatest common factor in this case, and I'll think of the greatest common factor of each of these numbers as being 4. So as we rewrite this, we can imagine both of them having the same denominator as 4. So I write both fractions with the same denominator, and I think 20 divided by 5 is 4. So 15 divided by 5 is 3. And 16 divided by 4 is 4. So 8 divided by 4 gives me 2. Now they have the same denominator. 3 minus 2 is 1. The denominator stays the same as 4. Knowing how to effectively add and subtract fractions can be a very useful skill when combining amounts in recipes, but also when we're thinking about very large numbers that need to be reduced and added or subtracted.